Hello everyone. The topic for Monday's lecture is going to be files. Whenever we use a computer, all of us have to deal with files and directories all the time. In fact, we have covered examples where we deal with file processing inside Python program. Recall that when we went through the topic of CSV, we covered a function which enables us to read the data from a CSV file and parse it into a list of list data structure. When we went through JSON topic, we went through two different functions. The first function enabled us to read the content of a JSON file into an appropriate data structure inside Python. The second function enabled us to take a dictionary's content and write it into a JSON format file. In today's lecture, we are going to cover more details about how to read the data from a file and how to write the data into a file. Recall that when we covered the generator functions lecture, I went through a snippet where I had description about the built-in open function call. The open function call enables us to read the content of a file, and the open function call returns a file object. A file object is an example of an iterator. Let me do a quick quiz here. What function call in Python will you have to use in order to determine whether a specific object is an iterator? Let me emphasize this clearly. I'm talking about iterator here. Go ahead and pause the lecture video here and write your answer in the comment section. The next thing which I want to talk about when it comes to file processing is you often run into exceptions when dealing with files. Just last lecture, we covered a lot of examples of exceptions, and we also covered how to deal with them using the try except blocks. Most of the exception examples that we covered during last lecture can be avoided. Let me give you an example. Let's say that you're trying to divide some number by x, and if x is 0, you run into zero division error, correct? So you can very easily avoid that by saying if x is not equal to 0, then go ahead with the division. Unfortunately, some of the exceptions that you might encounter with file processing cannot be dealt with in advance. Let me give you an example for that. Let's say that in your program, you're trying to write data into a new file and you run out of space in your hard disk. Then obviously you can't create the new file because there is no longer space on your hard disk. So you might be wondering, wait, can't I just add another if condition to check whether there is enough space in my hard disk and then go ahead and create my file? That might work sometimes, but it might not. Let me give you an example as to why it might not work. So your program is not the only program which runs on your computer. At the same time, your computer might be running many other programs and applications concurrently. Let's say that you did the check for your if condition, and before you actually go ahead and write the contents to the new file, another program comes in and takes the disk space and writes some other content onto the disk space. So it's not really possible for you to avoid such an exception. Instead, we are going to use the try except blocks for handling specific exceptions associated with file processing. Let me give you a quick overview of the learning objectives for today's lecture. We are going to first talk about opening and closing a file. Then we are going to talk about how to read the content of a file and how to write content into a file. After that, we'll be discussing a set of functions associated with the operating system module. Majority of these enable you to do something with a file or something with a directory. Then we'll be going through examples of handling file exceptions. Finally, we'll talk about the topic of encoding. It's a little bit of a tricky topic, but it's really important. Let's get started by talking about the open built-in function call. The open function call takes the path of the file that you want to open and read as the very first argument. Recall that you should always use relative path to your files to make sure that your program is portable. What is portability? When you take your program which you wrote in some OS, let's say Windows, and you're able to run the same program in some other OS, let's say Mac or Linux, then your program is considered portable. So let's go back to talking about open function call. We pass the relative path as the argument to the open function call. What does the open function call return? The open function call returns a file object for us. File object is an iterator. So recall that you can call the next function call in order to verify whether the file object is an iterator or not. So that provides you the answer to my previous question. Let me give you an example of a relative path. Let's assume that all of this code snippet is inside a script file called main.py. When we have a file called file.txt in the same directory as main.py, we should simply be able to say open file.txt by using the string file.txt. Let's go through a couple of more examples here. I have another directory called data inside the directory where I have main.py, and I can access any files inside the data directory by saying data/movies.csv. Notice that I'm using a forward slash, which means that I'm writing this code either on a Mac or on a Linux operating system. We'll be talking about how to write generic code that does not involve using specifically the forward slash or the backward slash in just another few slides. But for now, just consider this example. Let me give you one more example. Let's say that I'm trying to open a file inside snapshots directory. I would just say data/snapshots/a. After you get the file object, you're going to be able to use the file object to read the content of the file. We'll come back to this shortly. Before that, let me talk about the close function call. So the open and close function call are a pair of function calls. They always go together. Whenever I type an open function call, before even adding the lines of code which does the file processing, I go ahead and type out the close function call immediately so that I can be sure that I'm closing my file object. Technically, you could not use the close function call, but I really don't want any of you to do that. So I'll give you a couple of reasons as to why that's a really bad idea. So first thing is that sometimes if you don't close your file object, and if half of the file has been remaining in your RAM memory and hasn't actually been pushed to your hard disk, then you'll have a corrupted file which doesn't really have all of the contents that you tried to write. You really don't want that, so please avoid missing the close function call. The second reason is that you have limited number of options to keep open file objects. So you cannot have infinite file objects inside your program. So just to make sure that you don't run out of the limit, you always need to make sure to close your file object. This whole structure where you have the open function call and then some processing of your file and then the close function call is kind of like a protocol, not something which we have covered so far. So you should always follow the steps of your protocol in order. So you should first do the open, do the file content processing, and then finally do the close step over here. So it's sort of like a sandwich where your upper bread is going to be the open function call and your inner lettuce or meat, whatever is the stuffing inside your sandwich, is going to be the part where you're actually using the file, and the lower bread is going to be the close function call over here. So let's now talk about how we are going to use file objects. So the first thing that you can do with a file object is you can read data from it. We can Do that by using few options. Let me go through the first option here. You can use the read method, which just takes all of the contents of the file and returns to you a string which contains all of the content of the whole file. For example, I have the content inside file.txt as I promise to always close my files. And when you execute the read function, data variable is going to contain this string. Notice that we have the new line character explicitly written out in your string. When you open the file, you'll just see the new line as the beginning of the next line instead. So this is option number one. Let's talk about option number two. File objects are iterators. That means that you can call the next function on it and do a few other things which you can do with an iterator, right? Let's recall this crazy diagram that we went through in order to understand iterable and iterator terms. File object is an iterator. An iterator is iterable, so you should be able to do three things with it. You should be able to call the next function because it's an iterator. Since an iterator is iterable, you should be able to use it in a for loop of this format. And you should also be able to convert it into a list. So let me give you examples for all of these here. So the first example uses next. So what next function call is going to do is it will read the next line in your file and return that as a string for you. So if your file has multiple lines, you have to keep calling the next function over and over again to keep getting the next line. This particular example only reads the first line. So let's go through the next example over here, which uses a for loop. So I am saying for L in F, L as in line in F. I can go ahead and do something with each of the lines that I read out of the file object here. Notice that we always have a close function call. Do not forget doing that. The last option here is to convert your entire file's content into a list. Why does that work? Your file object is an iterator. Your iterator is iterable. It better be, otherwise the naming doesn't make any sense. And whenever you have an iterable, you can convert that into a list. So I can simply say list of f, and that's going to give me a list of strings where each string represents one line in my file's content. Let's talk about how to use a file object for writing data into a file. We are going to cover a new parameter for the open function call now. That's going to be the second parameter, which mentions what sort of mode do you want to open the file with. So the default value for that parameter is the R mode, which stands for read. So you can manage to open the file for reading without using the second argument. Whereas when you want to write content to a file, you'll have to explicitly pass W as the second argument to your open function call. There are many other modes available for you, like append mode and write append mode and things like that. You're not required to know any other mode other than R and W for the purpose of CS220 content, but you're more than welcome to go explore what other arguments you can pass to the second parameter over here. So when you open the file with the write mode, one thing that is going to happen first is that you're going to be able to use the write function call, which is the opposite of the read, right? So when you want to read the content of a file, you use the read function call. And when you want to write the content into a file, you're going to use the write function call. First thing that you should know is whenever you open your file with W mode, be really, really careful because that's going to erase the content of the file if it already exists. There is pretty much nothing you can do to recover the content of the file once you have erased it and saved new content to it. So please be really careful if you're trying out this example and be very aware of what file you're trying to write into. So if the file doesn't exist though, The open function call with the write mode will create a brand new file, and then you'll write content to it. So the write function call enables you to write a string or any other value to your file. And then you'll have to be really explicit about adding a new line into the file. All of us are so used to using print that you might think that new line will automatically be added to the end of the string that you're writing with the write function call, but unfortunately that's not true. I make this mistake so many times than any other mistake ever in Python. You should always add a new line wherever you want while you're writing content to your file. Right. You can either use a single write function call, which takes this one big whole string, or you can always use multiple write calls. So whenever you make the second write call, Python knows not to override whatever you wrote in the first write call over here. So you might be wondering, okay, how can I override the content of a file? So pretty much you'll have to close the current file object and open the file again using write mode. All right. So that's it for this video. In the next video, I'll talk about operating system module and associated functions.